Okay, you can't see that very well, but that's okay. So, this, you have two forces, and it wants you to find the magnitude of this, the magnitude of this, given these two angles, this force, right? So, first thing that I noticed when I did this is the resultant force is only in the y direction, which means if the sum of two things is only in the y direction, then the x forces have to be canceling it out, right? Or they're zero. So the way that I wrote it is I made one equation for my x forces and one equation for my y forces. So
you're really only worried about your y forces if you know your x forces are equal to 0.
Yeah.
Yeah. Okay.
But if you can make an equation for two of those, and you have two unknowns with your magnitude, then you have two equations and two variables, and you can solve for those. So the first one I did to start finding my x forces was, how would you find your x from this?
Be 500.
Ignore this for now, because you need, you're trying to find this magnitude, and it's equal to, you're going to set these equal to each other. So what I did is, to find your x component of this, it'd be your magnitude, which I can call this one B, this one C. So it'd be your magnitude of C times your cosine of 30. Do you see how I got that?
Yeah.
And that would be equal to your x component.
Oh, it's not.
But you're just saying this x component plus this x component are equal to 0.
Yeah. So then you can find the magnitude by doing that.
Yeah. And then same thing for your b, your cosine, or that'd be your cosine, that'd be your sine.
Yeah, because your x is opposite.
Of 45 is equal to 0. So you see how those two are equal to 0?
Yeah.
Same thing for your y, but it's equal to 500. So your c, then this would be sine of 30 now. And this would be your b with cosine of 45. Do you see that one?
Yeah.
As well. So now, this system, you want to just solve for one of your variables, and you can plug it in back to the other, right?
Yeah.
So it's easier with the 0, but you'd subtract the sine of 45, and then you divide by cosine 30, right?
Oh yeah,
To solve for C,
yeah.
if you wanted C. So if you did all that, that's going to give you your magnitude of C is equal to magnitude of B sine 45 divided by cosine 30.
Would it be negative magnitude B sine of 45? If you bring it over to the other side by subtraction?
Yes. I don't remember if that mattered or not, though. I'm going to ignore that for now, because I don't think it matters.
Okay.
Yeah. So then you take that and you can plug it back into here. So you have your 500, so now you have your magnitude of C. So you can say your magnitude of B sine 45 by cosine 30 sine 30 plus magnitude B cosine 45 is all equal to 500.
Yeah.
So all I did for my calculator for this one said sine of 45 divided by cosine of 30.
Which is 0.816.
And then times that by sine 30.
It's 0.408.
Yeah.
Oh, because then you just plug 0.408 times cosine of 45.
And then cosine of 45.
Is 0.707.
And then 0.707 plus 0.408.
It's 1.12.
1.12.
Also, then you subtract your 1.12 from your 500, and that's your magnitude B.
Divide, but yes.
Oh, yeah, you can combine like terms of 30.
Yeah, so take 500 divided by 1.12.
446.
And then that should be what your magnitude is for B. So along AB is what the problem calls it. And it was 446 newtons. Yeah. And then you do the same thing, or not the same thing, you just plug this back into either of these equations and solve for that. Yeah. So that part you just plug B back into here, solve it through, and you're left with your C, and that's your second magnitude.
Which, is that the other question on there?
Yeah, then your magnitude of C is what the other one was.
Yeah.
So if you just do that real quick, magnitude of C, I'm just going to use 0 because it's easier. Magnitude of C, cosine 30, plus 446, sine 45. So take this.
Yeah, that's 315.
Okay, and divide by cosine of 30.
That's something I didn't know how to do. Okay, 364.
Yeah, and that should be what your other. Yeah.
Okay.
So 364 is your next one. Because all you did was set your x is equal to 0, your y equal to 500 systems of equations to find both.
And I was just realizing that because your resultant force is only in the y, you could set that equal to 0 and then do a 1 algebra.
Yeah.
Yeah.
Yep.
Okay. That makes sense.